Welcome back to Cosmic Galaxy. In this video, we're discussing how NASA launches things into space. Make sure to like the video, subscribe to the channel, and hit the bell icon. Things are launched into space by loading them onto rockets with enough fuel, known as propellant, to lift them above the majority of the Earth's atmosphere. When a rocket reaches the appropriate distance from Earth, the satellite or spacecraft is released. They send satellites and spacecraft into orbit by strapping them to rockets loaded with tons of propellant. The propellants provide the rocket with enough energy to propel it away from the Earth's surface. Because of the gravitational pull of Earth, the largest and heaviest spacecraft requires the largest rockets and the most propellant. How does a rocket lift off? More than 300 years ago, a scientist named Isaac Newton established 3 fundamental laws that govern how things move. According to one of the laws, every action has an equal and opposite reaction. This is the most important concept underlying how rockets work. The exhaust from a rocket engine is directed downwards towards the ground. That is the driving force. As a result, the rocket starts moving in the opposite direction and lifts off the ground. That is the force of reaction. Once a rocket launches, will it keep going? That is not the case. The rocket is still being dragged down by the Earth's gravity. When a rocket burns propellants and emits exhaust, it produces thrust, which is an upward force. The rocket requires enough propellants to launch so that the thrust pushing the rocket up is greater than the force of gravity pulling the rocket down. A rocket must reach speeds of at least 17,800 miles per hour while flying above the majority of the atmosphere in a curved path around Earth. This prevents it from being dragged back down to the ground. What happens next, however, depends on where you want to go. How to orbit Earth? Assume you want to launch a satellite into orbit around the Earth. The rocket will take off, and once it reaches a certain distance from Earth, it will release the satellite. The satellite remains in orbit because it still has momentum, energy from the rocket that is pulling it in one direction. The gravity of the Earth pulls it in the opposite direction. This balance of gravity and momentum keeps the satellite in orbit around the Earth. Satellites in close orbit experience a stronger tug from Earth's gravity. They must travel faster than a satellite orbiting further away in order to stay in orbit. The International Space Station orbits about 250 miles above the Earth and travels at a speed of about 17,150 miles per hour. Compare that to tracking and data relay satellites, which help us get information to and from other NASA missions. These satellites orbit at a height of more than 22,000 miles and travel much slower, about 6,700 miles per hour, to maintain their high orbit. How to get to other planets? To overcome Earth's gravity, you'll need a fast-moving rocket to go to another planet. To do so, you would need to reach speeds of around 25,000 miles. But you'll also need to determine the best time to leave Earth in order to reach that planet. For example, Mars and Earth approach each other at their closest distance every 2 years. This is the best time to travel to Mars because it requires the least amount of propellant and time. However, you must launch your rocket at the correct time to ensure that the spacecraft and Mars arrive at the same location at the same time. Thank you for watching the video.